Hello everyone, I'm Zafar, and this is the second video in the series of studying vector calculus and differential forms from this book by John Hubbard and Barbara Hubbard. Last week I intended to do three sections in total. One section on Riemann integrability of Rn functions in Rn. One section on measure zero sets, which is over here. And one section on Fubini's theorem and iterated integrals. Actually, getting to compute integrals, I mean. I was able to complete those, and as expected, there were a lot of struggles, which I'm going to talk about in this video. Let me first start by the biggest struggle I faced during the week. So this exercise, it's a doubly start exercise, as you can see, and it's about proving that a certain set on the real number line does not have a well-defined volume. I struggled with this exercise for 2 days and wasn't able to make any progress. Luckily, I was able to resolve that confusion by using help from external sources, such as, ChatGPT and Discord, but it also taught me an important lesson on how to ask good questions. Let me read the problem statement first and show some of my work. Consider the subset U of the unit interval that is the union of the open intervals. Well, it's kind of erased in here, but it says P over Q minus C over Q cubed, comma P over Q plus C over Q cubed for all rational numbers P over Q in 0, 1. Show that for C greater than 0 sufficiently small, U is not pivable. By pivable, we mean the indicator function for this set is not integrable. It's basically a question asking, like, for a certain topologically defined set on the real number line, it does not have a well-defined volume, or by one-dimensional volume, I mean the length of that set. So I was thinking that if I need to show that the indicator function of U is not integrable, then I need to show that the oscillation of this indicator function is very high among the boundary of the set U. By high oscillation, I of course mean that the difference between the supremum and the infimum is always 1 on any dyadic interval of this form. And if you don't know, the indicator function only takes 0 or 1 as its output. So the supremum must be 1 and the infimum must be 0, which amounts to saying that for every dyadic interval, like this in red, there should be some portion of this subintervals in U that are, well, intersecting our dyadic interval, but there should also be some empty space, so to speak, so that the indicator function can take values either 1 or 0 on any dyadic interval. And this question was particularly tricky because you can't really visualize the set U, I guess. I was thinking it kind of looks like Cantor dust, the Cantor ternary set, but the difficulty with this one is that it's a union of open intervals, so the set U is also open. So, I wasn't able to make any progress despite working on it non-stop for 2 days. I eventually asked ChatGPT whether it happens to know anything, and it did know, like, the answer pretty spot on, like its proof was airtight. But, I wasn't able to reach that conclusion myself, so that's kind of unfortunate. So last time I had a similar struggle. It was about Taylor polynomials of implicitly defined functions. ChatGPT wasn't able to help me much. It was kind of spitting nonsense. And I decided to turn to Mathematics Stack Exchange and the Mathematics Discord servers for help. But despite posting my full attempts at a solution on these forums, I wasn't getting any responses, and most people seemed reluctant to give any hints. I realized that it wasn't that the question was too difficult or that the people didn't know the answer. It was really the matter of me asking a long and contrived question and nobody wanted to answer it. So my advice to anyone who is in a similar situation where they're stuck on an exercise or some concept and they need external help from online, know how to ask good questions. Because if your question is not very appealing to other people, since other people are working on a bring your own motivation kind of basis. If your question is not very appealing, then people are just not gonna answer it. But I would also say that it's worth listening to what ChatGPT has to say, because it might just know the answer like offhand, so to speak. It might just know the answer already. Next week, well, I also said last week that I wanted to do complex analysis, but it turned out that it wasn't a high priority thing. The biggest priority right now is participating and making good contributions to this RAU program I've signed up for over the summer. And since complex analysis is not really necessary for that one, I decided, well, I'm just gonna keep doing Hubbard and Hubbard and do my best in that RAU, so to speak. Next week, I think I'm also gonna aim for 3 sections. So 1 section on numerical methods of integration, 1 section on using other pavings, determinants, and this is a big one, and also volumes and determinants, section 4.9. So that's 4 sections. And of course, the RAU stuff is the goal for next week.